I can determine whether a number is prime or composite. In this lesson, we're going to learn two very important vocabulary words, prime and composite. Let's take a look at the essential question for today's lesson. How can you tell whether a number is prime or composite? Before we begin, let's review what you have learned about factors and arrays. So how does an array show two factors of a number? Pause this video and turn and talk to your partner. Okay, so how does an array show two factors of a number? Well, here's an example of an array here. So we can see that the factor here would be 2, and the factor up here would be 3, giving us the multiplication 2 times 3 equals 6, since you can clearly see that there are 2 rows of 3, amounting to 6 total squares in that rectangle. So in other words, the number of rows and the number in each row are the two factors of the whole number in the array. So here's another question. How does the factors modeled by a 2 by 3 array, such as in this one right here, and the factors modeled by a 3 by 2 array compare? So pause this video and turn and talk to your partner. How do the factors modeled by a 2 by 3 array compare to the factors modeled by a 3 by 2 array? Okay, so look at the factors that are modeled here by the 2 by 3 array and take a look at this array, which is modeled as a 3 by 2 array. So how are these factors comparing? Well, the factors are the same, aren't they? The factors are 3 and 2. However, their order is different. All right, so we're talking about the commutative property of multiplication here. Let's look at this following word problem. Students are arranging square tables to make one larger rectangular table. The students want to have several ways to arrange the tables. Should they use 12 or 13 tables? So what's the first thing we need to do? Well, as always, we need to make sure that we reread the question part of our word problem. So there's that question mark. There's the beginning of the sentence. This is our question. Should they use 12 or 13 tables? Now, let's go back and see what important information we are given in the word problem. Students are arranging square tables to make one larger rectangular table. Okay, so we know that they have square tables and they want to make it into one larger rectangular table. So let's go ahead and use a grid to show all the possible arrangements of 12 and 13 tables. So go ahead and pause this video. Turn open to page 305 if you'd like to do this in your workbook. Page 305, and pause this video until you're ready. Okay, so the first rectangle you could have come up with is this one. In this rectangle, we have one row by 12. So the multiplication equation for this would be 1 times 12. Another rectangle you could have come up with is this one. And in here we have 2 rows of 6 for the multiplication equation 2 times 6. Another rectangle you could have come up with is this one. This rectangle shows 3 rows of 4 for the multiplication equation 3 times 4. And there's actually one that you could have come up with for using 13 tables. The only rectangle you could have come up with would be just one row of 13 for the multiplication equation 1 times 13. So if you take a look here, there were 3 different ways to arrange the tables if they were to use 12 tables. But if they wanted to use 13 tables, there was only one arrangement. So looking at this, we can see that there are more ways to arrange 12 tables. So let's look back at the factors of 12. So we have 1, 2, 3, 4, 6, and 12. So what are the factors of 12? Well, again, we have 1, 2, 3, 4, 6, and 12. So if we're talking about 12, 12 would actually be a composite number. A composite number is a whole number greater than 1 that has more than 2 factors. And looking at 12, we can see that it has actually 1, 2, 3, 4, 5, 6 factors. Therefore, 12 is a composite number. But let's look at 13. What are the factors of 13? Well, looking back at our array here, remember, we were only able to make one array using 13. So it's only 1 and 13. So the factors of 13 are just simply 1 and 13. So the question is 13 a composite number? Remember, a composite number is a whole number greater than 1 that has more than 2 factors. So if we're looking at the number 13, it definitely is greater than 1, but it does not have more than 2 factors. It has exactly just the 2 factors. So 13 is not a composite number. 13 is a prime number. So what's a prime number? A prime number is a whole number greater than 1 that has exactly 2 factors, 1 and itself. Just like in 13, 1 and itself. So 13 is a prime number. So going back to our problem here, should they use 12 or 13 tables? Well, since 13 is a prime number, it only has 2 factors, so it would have only one arrangement, as we saw here. Since 12 is a composite number, it would have more than 2 factors, and so it would have more than one arrangement, as we discovered. So knowing whether 12 or 13 is a prime number or a composite number could have actually helped us solve this problem. Divisibility. You can use divisibility rules to help tell whether a number is prime or composite. If a number is divisible by any number other than 1 and itself, then the number is composite. So let's see what this means. Is 51 prime or composite? Well, let's consider this. Let's think about the divisibility rules. Is 51 divisible by 2? Well, no. Going by the divisibility rules, in order for a number to be divisible by 2, it has to be even. 51 is not even. Okay, well now let's check. Is 51 divisible by 3? Well, let's see. If the digits add it up, is divisible by 3, then it is. 5 plus 1 equals 6, and we know that 3 times 2 equals 6, then yes. So then 51 is composite. So in order to tell whether a number is prime or composite, we actually don't have to check for more factors to tell if 51 is prime or composite. Why? Pause this video and turn and talk to your partner. Why don't you have to check for more factors to tell whether 51 is prime or composite? Okay, so why don't you have to check for more factors to tell whether 51 is prime or composite? Well, if 51 has more than 2 factors, it is composite. So once we find a third factor, just like we did right here, then we can stop. The number of factors is not what is asked. So let's go back to our essential question. How can you tell whether a number is prime or composite? Pause this video and turn and talk to your partner. In this lesson, you learned how to determine whether a number is prime or composite.